First of all, hello everyone. Thank you, Pranay, for your overall understanding, giving us the understanding on decision trees and ensembling techniques, like how the boosting and bagging works, what are the different types we have in bagging and boosting. So I hope everyone got a better understanding on the ensembling techniques. Those are very, very important in our future. Those are playing very key role. As Pranay told, there are many institutions who are only mainly focusing on XGBoost. So you need to be very careful on understanding all these techniques and all for your better working on the machine learning models. And for today, we are in this session, we are going to discuss about the random forest technique, which is one of the powerful ensembling method. So imagine a team of smart decision trees working together, just like a group of experts combining their knowledge to make the best decision. This is how the random forest works. Random forest is having the multiple decision trees working behind the random forest to make it more accurate and giving us the better results. Whether we are classifying data into the categories or predicting numbers with accuracy, random forest will be able to handle all these things, and it will performs better on the data, by training and testing the data. In this session, we'll deep dive into the all the works, like how it works, why it became such a big game changer in machine learning algorithms and all. Let's see all those things in detail further. Now, so what exactly the random forest is? Imagine you're trying to I'll generalize the random forest algorithm for you, like in very simple methods and in our terms. That is nothing but imagine someone of you is trying to buy a car. Before buying a car, we'll go online, we'll check for the features which are best for us and all. But apart from doing all this online research, we'll be going to your friends or some of the relatives we know. We'll be asking not one friend for a decision, but it won't be it doesn't give us the better results or better one. If you take 100 friends and each friend looks into the specific categories like features of the car, like price, mileage, brand, etc., then you will correct the everyone's opinion and will you will go with the most suggestion which was given by the most people. So this is how the random forest will works basically. Like here we'll be having the multiple decision trees in the random forest. So we'll be giving the data set to the multiple decision trees. They'll be doing all the things and they'll be giving every decision tree, like it is nothing but every model will give us the particular output based on the voting, like voting on based on the higher number of output will be going that the with the same output. And coming to the ensembling learning means we are using multiple decision trees, like as in the ensembling methods we'll be using multiple models, we can use elastic regression, linear regression, we can use Navi bias, we can use decision trees, we can use any as per the ensembling methods we can use anything, but in random forest it will uses only the decision trees for making the predictions. So this is about the ensembling methods, and we'll go with the how it works, like how the random forest works and like what is from end to end. Yeah. The first one will be the bootstrap sampling. Uh, it is nothing but we are converting the whole data set into a number of subsets of data on based on the requirement. This is that is each subset will be having some features and some data points which are nothing but row samplings and feature samplings. If you want to see it practically, here you can see, right? This is the training set and data set. We have we are divided we have all these data. We are giving training data. We are converting the data sets into training data 1, training data 2, and training data n, and we are giving these data sets to the multiple decision trees, right? We'll be getting the output in this way. Bootstrap sampling is nothing but converting the data into the multiple data points, like multiple sub data sets. The subsets data may be repeated, like in the subset the data may be repeated. We can't assure that 100% it will divide the data into the unique categories. It may be repeated, but most of like 70 to 80% of the data will be unique. Like we will be giving the 70 to 80% of data, the new data to in the every subsets. And the second one will be tree growing, how the each tree will be constructed and how each tree will be grown, and with the help of the sub data sets. The each decision tree will be constructed based on the features and the data points. The nodes are split into the, as you know, the first one will be the node. The first node will be splitted into the child nodes based on the features. Now all the trees will be considers the first one as the feature, like it will split the trees based on the features, and it will be continuous as per the requirements on the given sub data sets. And now all these trees which are grown, these all the single trees are also considered as the base learners. All these base learners are also will be giving us a output that will be like more accurate. So instead of telling this all these as trees, we can also call them as base learners. Finally, the point is parallel processing. Here, all these base learners will be working parallelly and independently. There is like we'll be assigning the data to all the decision trees at a time, like for all the base learners at a time, and they'll start working on the data like parallel. There won't be any like waiting for other trees to be completed. They'll be giving, once they are done with the work, they'll be give their output. Once we get the output of all trees, then we'll be like doing the averages and all. And I think everyone will be getting a question here. That is how we will be considering the output, because we are working on multiple base learners, right? Each one will be giving us different outcomes. Let's discuss on how this will work with classification, the like classification outputs, and how it will be working in the regression output. I'll take you through that. That we will be seeing in this next slide. Yeah. Let's go with the classification process first. The each here, let's say we are trying to determine if an email is spam or not. I'm doing some type of classification here. Like I'm trying to find out the emails. I will be getting all the emails, right? Sometimes we'll be getting spam emails also. I'm trying to find out whether an email is spam or not. I'll be giving all the data set to my trees, and they'll be processing all the they'll be processing all the data, and they'll be giving me some output. Based on that output, I'll be going for the majority voting. This is nothing but if I have, let's say I have 100 base learners. In that 100 base learners, 60 of them gave me their output, like 60 of them gave me output as like spam email. That is a spam email. Then that will be our final answer. We'll be considering the spam as the output. This is how the classification works. And for the regression, let's imagine I'm trying to predict some house prices. Like I want to buy a house, and I'm giving this data set to the my algorithm and asking like what is the average price of the house in this particular location. So let's say the tree one says something around 2 lakhs, and tree two says something around 2 lakhs 20,000, and some trees says around like some around like 1 lakh 80,000 or 1 lakh 90,000. So by taking all these numbers, I'll be finding out the averages, like sum of all numbers divided by the total number of trees, right? Yeah, that is how like we'll be taking the average of the output as average as the output of for our regression problems. The majority voting as output for our classification problems. This is how we'll be considering the output for both the classification and regression problems. I hope everyone can understand this thing. And for the next slide, we'll be talking about the key parameters. Like the developing a model is one thing, and doing it like tuning it towards like more accurate to give us more accurate results is one thing. Like we cannot just develop a model and leave it like that. We need to make sure it works accurate. It gives the results that are particular to the people, like model results up to the point, like up to the like expectations that were that are given by us. So for to gain that, to do that, we need some parameters. Like in every algorithm, there will be some parameters. We need to change them. We need to try to use multiple things. And with the help of multiple things, we will be able to find which one is performing very better and which is giving us the better results. To do that, we'll be considering like these are the four key parameters for hyperparameter tuning in our algorithm. The first one will be n estimators, second one will be the max depth, and the third one will be the minimum sample split, and the fourth one will be the max features. When we are coming, let's discuss about in depth for each point, like each of these things. And let's first discuss about the n estimators. I hope everyone will be understanding the thing. Like from the title itself, we can understand that the number of n estimators is nothing but number of estimators. But, but this is the parameter to set how many trees we want, like how many decision based learners we are expecting by our model to be generated. More trees usually means better results, but takes the longer time to process. We need to consider this one also. Our model should be like should not take more time to process, right? It will give us the results in like nominal times itself. Here we can give multiple options with the help of n estimators to our algorithm, so that we can test them and get the best one out. Like at how many estimators it is performing better on all aspects. Uh, like for example, we'll be taking and 150 trees as one of the best thing we got. It will check all the things. What is the time consumption it is doing? How the accuracy is there? How the model is performing on testing data, how the model is performing on training data, how is the perform like how is the results of classification metrics and all the evaluation metrics. We'll be checking all these things, and these all things will be checked internally, and it will be giving us the one of the best trees out. So we'll be getting like which one will be giving us better. Like we need to find out which is better for us. This is how we'll be finding out which one is better for in terms of n estimators. Same way we'll be doing for the max depth also. The max depth is nothing but this will controls how much depth the decision tree should grow on up to. This is also will here also we'll be testing with different values. So like depth 1, depth 2, depth 3, or else we'll be giving different random depths. We'll go with random depths up to like which are required. Um, the depth is nothing but this is the root node, right? This is the first depth, depth 1. This is will be the child nodes. This is will be the leaf nodes. Will be giving the this is the depth 2. So this is the tree keep on growing. And minimum sample splits. The minimum sample splits required at a node controls granularity of tree splitting. So the what is the minimum values that we need to split the data? That is like we are deciding, we are telling the tree algorithm to split the tree only when it meets the minimum sample split condition. So and also we have the max features. Here we can also control how many number of features that can be considered for a best split. That we can give all these things in a multiple values. So finally, we can test all these parameters by defining multiple values in a set. So it will the our algorithm will take all these parameters and it will be going through all these things and checking and giving us the best one out. And we'll discuss about some of the advantages of random forest algorithm now. So these four are the like advantages of our NFS algorithm, that are nothing but superior accuracy, feature handling, overfitting prevention, versatility. And when coming to the superior accuracy, it's like having a team of experts instead of one person in our algorithm. You know, right? Like instead of one single tree in decision tree, we're having multiple models, like multiple base learners in our thing. So if we are having multiple people to like judge something, they'll definitely will be going to will be getting the better accuracy. They'll try to find out the better one. Let's say in the start, I have told you you're going to ask your friends, like multiple people to give their opinions on a single particular day purchase decision on car. So you have asked like 100 people. Definitely they'll gonna check all these things. Even if they are not checking, they'll have their own knowledge on like if they have the car. In this today's world, everyone will be having the cars, right? So they'll be going with their things and they'll check like, oh yeah, I have this car and this is the output I'm getting and I could suggest this to him. Like they'll be giving the like all their opinions to you. Finally, you'll be getting the better accuracy, right? You'll be getting the ultimate good decision only. So here the accuracy will be very high. And the next one will be feature handling. It can work with all kinds of data like numbers, categories. Uh, it is versatile. Like it can have all types of things. It can handle all the things, categorical things, segregation things, and all. So it will be able to handle all the features very precisely. Let's talk about the next one, overfitting condition. So in this thing, it will be able to prevent the overfitting condition because it uses many trees and averages their prediction. So it will be having very less chances to make mistakes, like from memorizing the training data. Like what is overfitting? It will be performing good on the training data, and it will be performing like bad on the testing data. Like that is nothing but unseen data. So here we are giving like multiple data sample data sets to the multiple data trees. So like multiple decision trees are base learners. They'll be like going through all the data. They'll be having all their independent decision. So here the chance of overfitting will be very low. So because like if let's say I have 1,000 data sets, like 1,000 data points, I'll be giving like 80% of data to my all the base learners. They'll be going through all the data. By these things, they'll be getting like what is like pattern of the data, how it will like what are the multiple features that are there, like how the multiple features are affecting the output and all. They'll be getting all these things. So if they're going through the few test data, definitely they're gonna perform well. And the third one will be versatility. It can handle many different types of problems without needing much data preparation and all. It works well for both, as I've told you previously, it works both well for the classification data and regression data. Let's see about like some of the limitations that are will be there with the random forest algorithm. Yeah, limitations that we are having in the like random forest algorithm. The first one will be computational resources. Here, the random forest will create many decision trees and combines their results. More trees like will give us better accuracy, but also process power and memory is like more processing power and memory is needed. Like it will take too much. It will take much time to process all these things, and it will give us like take need more power also. So let's say for example there is a chef cooking a meal for like one person or like up to 10%. It will be very easy. Cooking for 100 people means you need like a bigger kitchen, more ingredients and more time. Like for cooking a single meal you need like let's say 10 to 15, like half an hour to 1 hour. For cooking more than that, you need like 2 to 3 hours. Like here, if you're having multiple base learners or multiple things, you need more time to process all those things. This is how it works. Similarly, the random forest with many trees takes longer time and uses more computer power also. Model interpretability. This means a single decision tree is easy to understand because it can follows like normal steps. A random forest has many decision trees and they all make different decisions. So figuring out why the model made certain choice, like here in general, all the multiple, we'll be getting the outputs from multiple trees and we'll be getting finding out the average of like majority voting or average of those outputs to make an ultimate decision. For this we don't know like which tree we has given like which output and why it is giving like that, because like there are multiple trees, we can't just say like on how it gave, right? Let me generalize this for you. If one like you have a teacher and they are giving grades for you, you can go there directly and you can ask them like why you gave me this and this. Let's say you're going to some competitive exam and you got some results. Like you can't question them, right? Like there will be like multiple screenings that goes through the paper goes through and all. So you don't know like on what aspects they like gave you less score and what aspects they give you high score and all. So this is how it works. It will be somewhat confusing to know how why the model made such decisions sometimes. And next one will be the practical considerations. Why not to use it? This means like random forest is powerful, but sometimes it is much for simple tasks. We need to, based on the task, we need to like go with a decision like which algorithm should be used. We should not blindly go with the random forest algorithm for every problem, right? We need to check for like which problem needs which type of algorithm. So if your problem is simple and small, a basic logic like model like logistic regression is fine. But if your problem is bigger, then you need like better performing algorithm. So you need to consider in that way. This is all about the theory part on how the random forest works, what are its limitations, what are the advantages, what are the key parameters that were used to do the hyperparameter tuning, how it works, like what is the sampling, how the sampling works, how the tree grows, what is the parallel processing. And we have seen all these things till now. We'll see the practical things to get more knowledge on how the like algorithm works, how I'll be taking you all through like how the how it works for classification data, how it works for regression data. We will also see like what are the metrics for evaluating the classification model, what are the metrics for evaluating the regression model. We'll be seeing all these things in this practical now. Yeah. I hope everyone got better understanding on the theory part. So it is very important to know. And let's start with the random forest classifier. Here I'll be taking you through the random forest like classification problem first. First, the problem statement is the data. This is a data set that contains the car evaluation features. So here we have the columns like buying value, maintenance cost, door, like how many number of doors it have, how many number of persons it can accommodate, what is the boot space it have, what is the safety rating it have, and finally we have the target variable called class, like we are like whether it is unacceptable or it is acceptable car, it's a good or very good. These are all the columns we have. Let's start with the practical. So firstly, I have imported all the necessary libraries for me. Like for pandas is for reading the dataset. Trying test fleet is for splitting our data. We like in going further, I'll explain you all these things for you guys. Firstly, I have loaded my dataset using the pd.read_CSV. And then I'm printing the head of the data, we can the first 5 rows of the data, how it is, and to check how the data was. Here you can see buying value has the different feature, like different values, like very high, high, medium, low, and all. Maintenance is cost is also same, very high, low, and all. And coming to the doors, like it will be obviously it will be like numerical data, and the number of persons it can accommodate is numerical data, luggage space, safety, and class. These are all the categorical data. Here in the info, you can check like what are all the things, how they are here. And then we'll be checking with the missing values with the help of useNull. For checking just the a single column, we can use useNull. That we're using sum of to check is there anything in like whole column itself. For all the columns, we can do it at a single time itself. And then here we are doing like some data visualization process to get more understanding on data, how it is how it is skewed or not and all. Here I am using the count plot. And yeah, when we see at the visual, we can say that the data is like more skewed towards the unacceptable cars. So you can see like around it has like what is the total records we have? Mm, we have around like, just a minute.
1928.
Yeah. Let's say we have like 1728 rows of data, well, like these many data points we have. So in the data points, like 1700 of data points, we have like 12 per like 1200, mostly more data is like skewed towards the unacceptable thing. So the class variable is like this queue data will be giving makes our data set to be imbalanced. So let's say we are teaching a kid addition things, multiple things and all, like multiplication or division, subtractions and all. If you are giving, we need to tell them in a way like how the operations works. If you are telling every time like 2 plus 2 is equal to 4, 3 plus 1 is equal to 4, like you're giving all the outputs in a same way, if they'll be going to think that the output is like 4 only. So here, what's the mistake is like we are giving more data on the same thing, like same type. So we need to balance the data set. This is nothing but imbalance the data set. I'll show you with the plot also. Here you can see how the skewness is like. We have like this is right skewed data. So here we have the most like here the curve is over here and is going through like how the drop was. Like so this is like skewed data. So I'll be showing you in further how I'll be handling the skewness and all. And then I'm trying to encoding the data. So because for the missions we need to give all the numbers itself, but we have like variables in like out of 7 columns we have the 5 like columns with the data type objects. So we need to convert all of them into like integer data types to numerical data types, so that it will be kind of the mission will be able to understand them well. So that I am performing it with the help of label encoder. So here I'm going through every column and I'm performing label encoding on every column, and I'm saving all the label encoded data in the label encoders dictionary. So here you cannot see like label encoder dictionary, like it is containing all this data, label encoding data of buying value and all. And now here you can see the correlation between all the columns, like all the features that we have. Yeah, and then now I'm splitting the data, like now we need to like divide the data, like what are the like input data um, we are giving, like what is the output, like and all. Here I'm taking the y as my target variable, so I'm taking like apart from y, all the columns in the class like x variable and y in the target variable. And here we are using trying to split. So I'm taking these variables and splitting the data into x and y. I'm giving my test size as 20%. So 0.2 is nothing but 20%, and obviously the training data will be 80%. If we try, and you can see like training data has been like 1382 rows. The testing data remaining will be used for the testing purpose. And now see, here is where we are doing something to make our data more reducing the imbalances of our data set. Like as previously told here, here we can see the data is like more skewed. So to reduce this, we need to add like we need to make them equal, like there will be equal number of say data that should be given to our mission to train very well. We should not give the single monopoly data. So for reducing this grievance, I'm using something called SMOTE. SMOTE is nothing but it is a synthetic majority oversampling technique. We are also having something called random majority class removal. It is nothing but undersampling. As we have very small data set, so like removing the data using undersampling will create like will be able to make our data underfitting. So instead of this, in this small data conditions, we can go with smart, because it will try to add new data. It will not remove the data. Instead of removing the data, it will try to like add more data and make that balancedness that we want. See, I have performed the smart fit over here for my like training data. I'm not doing this for testing data because I just want to train my model with the proper data. Like anyway, like for the testing unseen data, it should perform like normally only. We should not do, we am doing just for that purpose. We am doing only for the X train and Y train data. And you can see the class variable distribution before smart is like we have these values, and like 975 of unacceptable data. After doing this, all the data has been equalized. So we will be giving the similar data to all like same data points to like target variable to our model for training purpose. And then I'm taking my random forest algorithm here. Like I have random forest classifier. As here we perform the classification problem, we need to use the random forest classifier. For the regression problems, we have the random forest regressor. So I'm taking the data and then I'm fitting my I'm fitting my model with the help of training data, which is nothing but the smart data that is resampled after doing the smart technique. Then I'm performing the prediction. Like here I'm checking my accuracy score for that. I got like 97% of the accuracy, and this is the classification report that you can see, like precision, what is the precision, what is the recall, what is the front score, what is the support score, and all. After doing all these, we'll be going with something called hyperparameter tuning. As I've previously told you, like what is the high, like why it is required and why we'll be doing all those things and all. Like here we need to firstly I'm defining all the parameters that I want, like as I previously told you in the slide theory part, like an estimators, max depth, max sample split, minimum sample split, all these things are required like for performing the hyperparameter tuning. These are the parameters that will be useful to do that. So then uh, to know all these parameters, like we should it is sometimes it will be possible to remember, and if sometimes it may be not be possible to do that. So for the things you can go to here and you can just like random forest classifier. Here you can directly get like what are all the parameters that we can use to optimize the random forest classifier. See, like we have an estimators, we have the max depth, max minimum sample split, minimum leaf split, what is the weight fraction and all. These are the parameters, all these parameters that we have for to do the hyperparameter purpose. So in this way, we can go to the documentation and we can check what are the parameters and also in the bottom we'll be having all the like exact definitions and what is the how we can take the values for that and all. You will have all this data in documentation. So it is better to check the documentation if you're stuck anywhere. And these are all the parameters I'm defining. Like for n estimators, I'm checking with the different and is like different number of base learners. Nothing but estimators like a different number of estimators like 50, 100, 150 and all. I'm checking for the max day. I'm giving the max day, minimum sample split, minimum leaf and all. And I'm using the grid search CV for the hyperparameter tuning. We have like this is one of the technique that is used for hyperparameter tuning. We have one more also, that is random search CV. In grid search CV, it will go through all the combinations. Like if we are giving like uh, all these things, right? It will check all the combinations. It will take 50 n estimators. It will go with none depth. It will go with the two samples and all. And for every estimator, it will check for all these things. For 100 at most, it will continue all these all these things again. It will check for 150 estimators also. It will check all these things again. This is how the grid search CV works. But when it comes to the random search CV, it may not take all these conditions. It may take like a few random conditions and it will check for the few random conditions only. It will not check for all these conditions that are mentioned by us. This is how the grid search CV or random search CV works. And in grid search CV, firstly we need to define what is our algorithm, like for which algorithm we are doing this parameter tuning. We need to define that algorithm. And then we are defining what is our parameters. Like I've told you, right? What are the parameters we are using for to do the optimization, and what is the cross validation value we are using. Like cross validation is nothing but giving the folds. Like if you let's say we have 100 rows of data. So if I'm giving 5 folds, it will divide my data into 5 folds. That is nothing but each fold will be having 20 data points. So this is how it will works. And I'm fitting my grid search CV model with the help of like all the training data. And again, I'm trying to do the prediction and all. I'm checking my accuracy. I'm checking all the classification metrics as previous. What is the precision, recall, F1 score, and support score. And here comes the best thing is, here we can check what are the best parameters, like what is the which parameters made the best performance for us. Here you can see the max depth of 20, minimum sample leaf of 1, maximum split of 2, and n estimators of 150. Like these parameters gave us the best results. These made like not about the best results. They in all the aspects I have told you, right? During these conditions, it will check all the parameters like time computation, power computation. It will go through all these things, right? Anyway, like in the ultimate decision is to our ultimate goal is to get the optimized model and like better perform optimized and better performing model. So these are the parameters that helps that made like best performance, like optimized performance in the grid search CV. Like it will check into the random combinations. Right? This is the combination that helps, like that is like more better. And this is the best like cross validation score like 98%. You can see it is better like than previous. So this is all about how we will be working on random forest classifier. These are the like parameters that we'll be using for the accuracy classification report. These are the parameters we'll be using to check like how how this model is performing. For the classification purpose, for the regression purpose, we'll be using the different ones. I'll take you through that one also. I hope everyone got better understanding on this practical example of random forest classifier. Mm, we'll go through the random forest regressor now. Just a minute. Yeah. Um, this practical set is for the random forest regressor. The problem statement is this data point is containing all the features like what are the features in an building like house. So what is the number of bathrooms it has, number of the bedrooms it has, what is the square feet of the house, what is the latitude of the house, what is the longitude of the house, what is the use code, what is the neighborhood, what like how many total number of rooms in the house, on which year it was built, on what is the zip code of the house and all. And finally, we are predicting the price of the house. Like our target, based on these things, our target variable will be price of the house. Like these are all from this data set, we are going to predict what is the price of our house. So prices will be varying. There won't be like in classifications, we have only like yes or no, maybe like up to four or five variable, like five different types of things. So as we see here, we have like in the classification thing, we have like four things, right? Unacceptable, acceptable, good, and very good. These are the category variables. Like these are the categorical things we have in our class variable. So in regressor, we'll be having n numbers. We can't say like this. So in regression, we'll be following different approach apart from the classifier. So in the same way, I have imported all my required libraries here, and I have loaded my data set like which is stored in my local desktop. And then I'm checking the top rows as using the mm, head command, and you can use the tail command to check the like last five rows. If you want to see like whole data of head and tail, you can just give the df, so that you'll be able to see the top five rows and the last five rows of the data. This is the shape of our data, and 439, we have the 439 data points over here. And this is the info of our data, like what are all the data types that we have in our data, like float, int, object, and all. And I'm checking for the null values as the same I've told you. There is no null values as I told you. And then I'm checking some statistical parameters. The df dot describe is a thing that will help that will give us the statistical parameters of our data set, especially for numerical columns. So we can perform the statistical things only for the numerical parameters, right? So you can see the count, mean of the whole column, standard deviation of the whole column, what is the minimum value of the whole column, what is the 25% of the value, what is the 50% of the value, what is the 75% of value, what is the max value of that column we have. We can check all these types of statistical parameters to our data, like no, to our which is nothing but our data set. For every column, we can go through all these data points, for all the columns we have bathroom, number of bathrooms, number of bedrooms, number of like what is square feet of the whole house, what's the latitude, what is the longitude, what's the total number of rooms, what is the year built, what is the zip code, what is the price of the house and all. So here you can we can see that for use code and neighborhood we have the categorical data. So for this we need to convert, as I previously told you, we need to do the encoding to make them into the numerical variable. So it will be easy for our machine to learn from that. So this is as the same way as I've told you previously, I'm doing the label encoding over here. I'm taking a data set like dictionary to save all this data. So here I'm just like in the previously I've used all the columns which are like categorical to perform the label and column. Here I just have two columns, so I'm just defining their column names to make sure it will goes through only these columns. So for column in categorical columns, I'm doing a label encoding. I'm fitting these things and I'm like saving all the data into the label encoders. Here, after performing the label encoding, you can see all the data is in numerical variables. So it will numerical value. So it will be better for us to like train our things and all. And then now we are going to see like how the data, we are going to split the data, like we need to split our data, right? For the training and testing purpose. So I'm splitting all my independent features into like X and all the the target variable into Y. And then I'm splitting my data like X train, X test, Y train, Y test. I'm using the same one, train test split library. So here also I'm using the like 20% of the test value like, and 80% of the data for a testing purpose, like sorry, training purpose. And here, as I previously told you, for using the classifier, we use the random forest classifier. For the regressor, we use using random forest regressor. So this is the just different thing that we're using. So same way we are will be assigning our model. We will be fitting like X train and Y train values, Y train data, and we will be predicting the test data. Like for unseen data, we'll be testing the accuracy, like how the data is performing and all. And for when it comes to this, we'll be checking the different evaluation parameters in terms of regression problems. In regression, we are using the mean squared error, mean absolute error, and root mean square error for the evaluation purpose. So here we'll not be using anything called accuracy. So to get what the direct values, so we're using something called these things like mean square error. What is the error that is making? This is nothing but how the error is, like what is the mean squared error between the actual values, like what is the actual test values and the what are the predicted values. So we are going to check the mean square error between these things. And the same way, I'm going to get the param grids, like how what are the parameters that are required for our hyperparameter tuning purpose. I'm these things like all these things as I've told you previously, and estimators, max depth, max features, minimum sample leaf, minimum sample split, and all. Here I'm using the GridSearchCV. So I'm giving, this is like in here, we have defined our GridSearchCV like directly by giving the values over here. This is how it, like we can use this way also. This is the other way how we can define the values. Like see, we can use estimator is equal to model. Like we are assigning to a variable like param grid. Like for random set CV, it will be the param distribution. The variable will be assigning like CV value as I've told you previously. Cross validation value if it is 5, and we'll be training the data, and we'll be going through like testing purpose, like testing our data. So the like you can see for before testing and after testing, the error value has been reduced. So that means the performance of the model has been increased by somewhat. You can see the error value is around like 90 and all. Mm, root mean will go with the root mean squared error. It is like 9,49,000, and you can see here the error is like reduced to 69,000. That means the error has been reduced. So with the help of by doing the hyperparameter tuning, the error will be reducing absolutely, like it will be reduced. So if you want, we can do like further optimizations also to make it like more better in a way. And these are the best params that has given the better results in our model. So max depth is 10 and max features are 4. Minimum sample split is leaf is 4. Like a minimum sample split is 5. N estimators are 50 estimators. These for regression problem. These are the parameters that gave the better results. If you want to check the parameters for the grid search history also, we can go here. Yeah, you can see here like for estimator, like for gradam search CV, these are the parameters that we need to assign to that. So we can get we will be getting what is the data and like things. And for random search CV also we can check. Okay. See, like you can see for the grid search CV, the variable name is like param grid. For random search CV, it will be the param distributions. As I gave you the better, like as I previously told you, what is how the grid search like grid search CV will works and how the random search CV will works. And this is all about our regression, like a random forest algorithm, how it works for the how it works for our classification problems, how it works for our regression problems, how we can go through all the practical things, how we can do the hyperparameter tuning process, how it may like how the hyperparameter tuning will help us. What are the parameters that we are like we have to use in the for doing the hyperparameter tuning, and what are the best how to get the like best parameters that worked well for our algorithm. Today, these are all the things that we have seen in the today's session. We have seen the theory things and the practical things and all. And the main thing is like as you need to like practice all these things. After this session, we will be sharing all these recordings with you all. So you need to go through all these things and do the practice. Doing the more practice and more practical, doing more research on these things will give you better understanding, and you will try to get more knowledge on how this works and what are the different things we can perform, what are the different ways we can do, what are the different ways to optimize the algorithm more and all. So this is all about the random forest algorithm. Thank you all for joining the class and having the patience and listening all this class. If you have if any doubts, you can post in the chat. We'll go through the routes and we'll give you the clarification. Thank you so much for joining the class.
Thank you for watching. Please like, share and subscribe to KKR Gen AI Innovations channel.